All right, cool. I think I've got this set up live. Okay, yeah, it should be live. And I just got to tell the Discord channel and put a link on here for the list Discord channel. Okay, there's the Discord invite link. And I've already told the Discord channel. And we'll kick things off at 10:45. This is a video that I've done before, but it was really old, and I just think that we can do a little bit better now and cover a good variety of approaches. It might be a nice opportunity to kind of like show how much we've kind of grown here. Yeah, I'll see you guys at 10:45 though. Okay, we are probably good to go ahead and get started. Looks like I missed a little bit of the chat. I was actually kind of making some last notes. I actually have like at least 6 approaches. You know what? Let me get rid of this first. All right, I got like at least 6 approaches for this problem. In fact, I got this little file over here. It's actually from like December or January. It's like I think it's at least 6 months old, but I've been sitting on like 7 approaches for this problem. I don't know if I actually like some of the approaches in here. They were a little bit more naive or weird. Maybe we'll get to them anyways, just because they're kind of interesting. I'll go ahead and post this at the end, by the way. But I've literally had like at least 4 solid approaches for like 6 months now, and it's like I think I only covered like 1 or 2 in my original video, and so I've just been like I really want to cover this again, and so that's why we're doing it. Again, I'll post this at the end. Let me go through the chat a little bit. This is my favorite classic problem. Usually I've seen hashing being used to give the shortened URL, but would love to see how. So yeah, it's usually with tiny URL, a lot of people like get really focused on that hashing piece. And like, I don't really care much for the hashing piece. It's like, okay, so you're going to map each URL to a unique one somehow, but I don't really care about that. So I like to really kind of outsource that and just focus on the actual scaling aspect. And this one actually has some really fascinating stuff that you can do with caching. And a lot of my continued discussion after the original coverage, like within the Discord channel, has focused a lot on that caching aspect, which I'm going to also explore in some other more sophisticated problems probably over the next month or two. Like one of Google's favorite problems is like cache controller, or like just straight up design a cache or something. I don't know if hashing indeed is the only scalable approach for this problem. I mean, hashing, it's like you're going to have to need, you're going to need to have some kind of shortened thing, but like it's, I mean, if you try and look at like the caching part, a lot of what I'm going to cover for like the different approaches is going to focus a little bit more on the caching aspect, which is where we're going to see a little bit more variation here. Am I muted? Can you guys hear? Oh, it hasn't started yet. Okay, good. Somebody was asking if they could, you said they couldn't hear me, and it's because, yeah, I give people about 15 minutes to join before I start talking. Use CQRS also. Yeah, okay. So that's, yeah, we're getting ahead a little bit. You know what? I can go ahead and kick things off with the monolith approach. So we're so used to seeing microservices everywhere, and I know that was like something that was recently talked about a lot in the software development community. Is there was this big paper at Amazon called Microservices to Monolith or something. As usually we're used to like putting in a system design interview, usually we stick everything on a different endpoint. Let's go ahead and start off with the monolith approach, which I did actually have over here. I think I covered it 6 was monolith. Yeah, but I did even talk about a monolith approach in that. And this is even old. I think I even have an extra approach or 2 that I've come up with after this thing. I don't know if I'm actually going to cover this. Maybe I'll do it briefly. All right, yeah, let's go ahead and jump in now. All right, so we got 2 use cases that we're going to support. It's you know, uploading the link and having that shortened, and then also users visiting the shortened link and getting redirected. So we got posting the link and shortening it, and then we also got the user getting redirected. So this is the redirected user, and then we have the link shortening user. And we can just go ahead and start off with our monolith backend service, or monolith service. And it's going to host 2 endpoints, and then you're going to have your database, your link DB over here. like we're very used to, oh geez, why did it not have, there we go. We're so used to just jumping into like separating this into two different endpoints. So this guy mentioned CQRS. That's absolutely, yeah, that's absolutely a thing. But you know, you've got this guy, hey, here's my link that I want to shorten. And then you know, you write it to your link DB. Let's go ahead and curve that. There we go. And then you get your response. And then with that same service, you know, you can go ahead and send it in, and it's like, hey, I'm visiting this short link. Where does it go? You do your read request, and you get your response back. And you can just go ahead and have that hosted on the same service. And so the pros and cons of that, the pro is like, hey, it's simpler. The con is that you're not able to scale these two different operations independently. You're of course going to get way more traffic over on this route than if you were going over on this route. There's a lot more users being redirected than users who are shortening links. So you can't scale them independently. You also can't deploy the updates for it independently. So then if you need to do a rollback of one of those two endpoints, like the development and updates to it are tightly coupled. So I mean, there's some, Shopify is apparently a monolith. So I don't even know if I want to label this as naive. We're just going to say it's just straight up approach one, monolith. It's an approach. It's an approach. Let's talk about the DB schema really briefly. And then I also need to talk about the UUIDs. I forgot about that. You know what? Let's go ahead and do that first. Let's go ahead and talk about that first. I like to just kind of outsource it when I'm doing this problem, because we've all seen the hashing stuff where you just give it the URL in, and then it converts it into some little hash code or something. So you got your request come in, and then it's going to go ahead and ask this service for a UUID for that link, for the link that you've provided it. And then it gives you a number back. Or you don't even need to provide the link. It might just be a sequencer. So like in leaderless databases, they actually have this like sequencer component. If you try and support serializable, linearizable transactions in a leaderless DB, you have that clock sync issue, and a common way to try and actually get linearizability with them is to just outsource it to this like sequencer component, which is a little bit like that sequencer from the stock exchange problem from last week. But yeah, we're just going to go ahead and outsource that UUID generation to a like sequencer kind of a component. So request comes in, get a UUID, we're going to persist it. And now I can talk about the schema. Say UUID. I see the question in the chat. I'll get to you in a second here. So we've got the UUID, and then we've got we need the long URL, and we're going to say that we're going to shorten wikipedia.com/system_design, and then we got our short URL, and we're going to say https://tinyurl.com/efabc. So we just call it, we're just making a GET request, and then we're just going to get back from that. We're going to get back EEFABC. Get right over top of that link. I don't like that. There we go. That's just the response we're getting back from it, is just that. We persist it. You would probably want to have the user ID in here as well. Just for like, hey, modifying your own link, seeing your own link stats. We're not going to have seeing the link stats within the scope of this. It's basically just the ad click counter problem, which I've covered in a separate video, and I'd rather just focus on the interesting cache stuff in this one. Okay. There was a question about the Discord invite. I did post that in the top of the live comments. I'm going to go ahead and post that one more time. There it is. do we need authenticated user here? You would maybe I think you can do anonymous link shortening on some services. I don't know how in the heck it works. Oh, I think they like subsidize it by having some premium features. So it's like a freemium thing where you can do some free link shortening, but if you actually want to see the stats on your links, you have to like make an account or something. I don't want to focus on authentication itself just because that's it's usually not something that people want to focus on a lot in a system design interview. And like, I mean, we usually like to go a little bit deeper, but it's it's OAuth. It's a pretty standard thing. It's kind of common to a lot of problems. It's not exactly anything particularly special to this specific problem, but yeah, you probably want to do authentication for this part right here. This part would not be authenticated because you should you don't have to sign into tiny URL whenever you're getting redirected, and it should be sending back a 301 or a 304X, of course. I don't remember. One of them's temporary, the other one's permanent. I think usually you go with the permanent option, but there are some link direction services that allow you to change the target destination after making the link. And so in that case, you'd want to do a temporary one. URLs generate the same UUID as they are created based on hashing. So the potential for hash collisions, yeah, I did want to just kind of like leave that. I didn't want to focus on the hashing aspect. So I'm like, it's a sequencer. There's ways you can set it up to make sure that they don't result in collisions. I just don't really want to focus on it. I'd rather focus on the caching aspects. You know what? I don't know why I did that. Yeah, that'd probably be a better idea. And the UUID would be the partitioning key, the primary key as well. So this is the primary key, and then you don't really need a sort key. If anything, you could maybe use that as a sort key, but I don't think it's really necessary. I mean, if you want to see all the links by a specific user, so like a user logging in and seeing all their links, you'd probably want that to be you probably don't want that to be scatter gathered, and so this would probably be a good option for a sort key. I'll go ahead and do that really quick. Although, like, if you have one power user and they tend to make some links that are really popular, like for example, if there's a company that has a premium account, you might, I imagine the users over here doing reads is going to be so rare that you might be okay with the scatter gather. It might be, you might be getting those key range queries infrequently enough that the scatter gather is not really going to make a huge difference. But it's depending on how the variation of the problem that you get, you could possibly want to do the user ID as a sort key. Well, okay. Right. Actually, it would not be a sort key. It would be the first part of the partitioning key. It's because if it was sort key, that would not prevent the scatter gather. It would have to be the first part of the partition key. You'd want to partition first by user ID and then the UUID. But again, that's just in a specific scenario. But I'd imagine that having power users like a company that just makes these really frequently accessed short links is probably going to be a bigger issue than the scatter gathers off of like looking at your list of URLs. Okay. Yeah, let's keep going. I wanted to cover the CQRS approach. Yeah, let's go ahead and move on to the CQRS approach. And this is still without a cache. We have approach 2 CQRS. And so we're going to keep the Now let's go ahead and I'm going to detach this thing, and we want to get rid of the monolith service. I'm going to take this and move that. And then we're going to have two different backend services. One of them is going to be doing write operations, and the other one will be doing the redirects. Okay, we have the link Shortener service, and then we have the redirect service. Okay, so you have a request come in, you do the UUID call, and then you're going to write it over here. And then you're going to get your response back. And then over here, you get your request come in. And then you're going to go ahead and you're going to do your read against this. And you get your response back, and you do your 301 or your 304 redirect. CQRS, we're still not doing a cache quite yet. We're just keeping it simple still. We're doing kind of like progressively more complexity as we're going through the approaches, kind of. I'll cover a cache approach next. Right. Come on. I'm trying to look at the chat. Are there any hosted UUID services? So I think you can use Zookeeper as a sequencer. But there's other stuff that are like made for the idea of it. Like I think Twitter Snowflake. I heard Twitter Snowflake can actually create some collisions. I thought that the idea though, I think should be a little bit like Lampert timestamps, where you have a machine ID combined with a timestamp, or just a sequence count. It should just be a monotonic counter is all you really need. So if you ever looked at like the COPS solution for causal consistency, that's COPS. I don't know if COPS is actually the right one, or if it's just like a vector clock or a logical clock, but you just need like a monotonically increasing counter. And just combine that with the machine ID, and it won't result in any kind of collisions. And so the monotonic counter, when you have it on a single machine, you can inherently make sure that it's going to be monotonically increasing. You can just generate a whole batch of those at once on the given machine, and then just serve them up. But that's why I don't really want to dive into it. I mean, you want something that will be short too, like DEF ABC. And just walking through how to make it the most compact, short, little unique identifier while doing both these two things is just not a really fascinating distributed systems problem. Like it's just this with some hashing magic, just some little hashing trickery as well. So that's why I'm not really focusing on it. And I think Zookeeper might have some kind of sequencer capability that you can use. Zookeeper as a whole is typically a cop-out, and so I do feel kind of guilty like saying, hey, just throw Zookeeper at it, because it's such a cop-out as a component. But again, I just don't really want to focus on the sequencer aspect of this. Can we add machine ID and UUID? Yeah, that would be a good idea. I believe UUID would be same for the long URLs. Correct. It should be, I don't think it would generate the same UUID every single time with the way that I've got this set up. Yeah, so maybe doing some kind of deduping trick might be a good idea, but like again, that's also kind of trivial and not what I actually want to focus on. But that would be, I don't think it would really hurt if you screw up on your call and your retry ends up generating a duplicate link. I don't think that would cause as much harm. Like the potential for causing harm with that is very minimal, as opposed to like in a payment service where doing a retry and creating a duplicated record would mean that you get double charge, which is a huge no-no. I guess in programmatic aspect, it'd be kind of obnoxious. But you would see the first one fail, and then in the second one, you have the one that would actually get used in your like higher leveled service. Pin sequence, no, also works for hashing. Do we need to compare UAT? I don't like that. That's exactly what I don't like to dive into the details of. So I think it was about a year and a half ago that I did like 10 different on-site interviews in about 2 weeks. And I got questions like web crawler. I actually got ad click counter. I got a couple of other ones. I never once received the tiny URL problem. And none of the problems that I did receive were anything like comparing hashing algorithms. In fact, I even received the rate limiter problem. And I really impressed my interviewer, who was like a senior staff level engineer. They were like really impressed with what I had done. I think they were a staff engineer at Pinterest, and they were like really blown away by my rate limiting performance. But like I never once went over like the three different rate limiter algorithms that Alex Shu covered. And I went over a bunch of different approaches, but nothing about the like windowing algorithm or whatever. So out of those 10 on-site interviews, I received 6 offers too. I literally had 6 competing offers. I never really once talked about like lower level algorithms like that. So that's why I don't really like those, but I don't really think so. It's usually not what's covered. It's usually higher level components, like what I'm kind of trying to do. I'm going to do one more question, and then we're going to move on to more approaches. Is a partitioning key the same as a composite key or clustered index? Oh, shoot, that, okay, so a composite key, I think that's when your key is made out of multiple columns, and that's, I think you're talking a little bit about the kind of stuff that you'd specify in PostgreSQL. So when you're working with DynamoDB, your primary key equals your partitioning key plus your sort key. And so this one determines what machine. And then your sort key is just for making it uniquely identifiable. But it also sorts it within a machine. So for a composite key, I'm fairly certain that's just like a key that's composed of multiple attributes. And you don't actually need a sort key. Sort keys are optional. So sort keys are actually optional. You don't actually need them. So if your partition key is uniquely identifiable on its own, you definitely don't need a sort key. It's purely optional to provide one. And then I think a clustered index, composite might be the same thing as a concatenated index or a concatenated key. It's where you just have it sorted by A and then B. And then a clustered index, I think that's where you like include an extra attribute in. And so usually when you create a secondary index, so if I was to make a secondary index over just the user ID, that would mean that just the user ID is within that index. And so then after I'm done finding my specific records, I would then have to do a second check against the hard disk to look up the rest of the attributes if I wanted them. But for a clustered index, I think it just puts them into the index itself rather than having to like look up on disk that the rest of the full record. So like if you have a record that has like 20 attributes on it, and you do an index over a specific attribute, it will just only have that one. It will just have that one attribute in the B tree. And if you like wanted to know any of the other information in the select, in that first clause of the select statement, you would have to do like a second hit on the disk to like get the rest of the information for it after you know the specific offset and like of like exactly where that record is on disk. You like figure out the exact record and then you like go to that record on disk and read off the rest of the attributes. It doesn't actually store the full record in the B tree when you're indexing by a specific thing. That would actually make it a lot. I think there's information on this over in DDIA and database internals if you want to check out more. So I'll write that here for more info. I think it's like the storage retrieval chapter in DDIA. It's like chapter 2 or 3, and it covers B trees and LSM trees. And then you also have database internals by what is it, Alex Petrov? I have his book right next to me. That's another good book for it. Let's go ahead and move on to more approaches. I want to cover some caching approaches now. So we're going to cover my naive approach that I'm going to call it naive. I'm going to first cover my naive approach from back in the fall, from like roughly a year ago. I just feel it's kind of naive now. I was a senior engineer when I wrote it. So, I mean, it is senior engineer quality, allegedly, but I don't know. I've covered like an extra 40 or 50 problems since originally writing the solution for this. So request comes in, you get your UUID, you go ahead and stick that onto Kafka. So that's you tell Kafka, hey, store this, and then you're done. And then you send your response back to here. And then you got your task runners. It's just some Lambda triggers. That's what you have in AWS is you have Lambda triggers set up for Kinesis. And so they actually have to do a pull off of that. And then you're going to write to your proper data store, which will be something like DynamoDB or something. And then you're also going to have your link cache. It'll be something like Redis. You're going to write it to both. And then, and this one would just have, again, just the UUID or, yes, the UUID is part of the short URL. And so in the cache, you're just going to map from that UUID to the long URL. I don't know if we really need to have both the UUID attribute and the short URL attribute. We probably just need the UUID one. And then the translation between these two things can just be business logic. It just doesn't need to really be on the database. So anyways, we're going to write to both. And because it's here, it's easier to do the retries. You wouldn't be doing the retries to get it onto both on the service. And you got this, your request comes in. And the first thing you're going to do is you're going to check the cache. And then if it's not on the cache, I'm just assuming it's like a LRU cache. If it's not on the cache, you get a cache miss. Time to check this thing. Time to check your database, your DynamoDB instance, and then you can go ahead and return the response over here. But if you get a cache hit, you don't have to check the database. You just have it immediately, and then you send it back. And that was my, I'm going to call this approach 3, message broker. I want to show you what happens if we don't have a broker, though. I want to show you why I even wanted to put the broker there in the first place. At the time that I originally wrote this, I was not a fan of DB triggers, and that's why I thought this was cool. I thought DB triggers were weird for whatever reason. And so instead of having this whole thing, my assumption was that the only solid alternative was that you would do the write to both. So like I knew you could do a lazy loaded cache. All right. But I was like, what if you wanted to do an eager loaded cache? So you have a request come in, you get your UUID, and then you're going to first write it to the link DB, and then it's going to tell you back like, yep, I got it. And then you're going to do your write to the cache, and then it's going to say, yep, got it. And then you got that partial failure scenario between these two things. That's why I didn't like this approach. That's why I thought my message broker approach was superior, is that I thought, well, what about that partial failure scenario between this call and this call? Because you need both of those to succeed, and then you would return a response. You, of course, have a failure scenario between the UUID service and the link DB as well. You would just end up wasting a UUID though, which is not really a big deal. So the partial failure between here and here is not really a big deal. And then I have no idea why I thought it would be weird to, you'd of course first want to have it in the link DB. And then if you had the partial fail over here, I think you would end up having to retry the whole thing, because it would assume that you had a fault. You might return a 50X if this one fails. You could return a 50X, or you could just go ahead and give them a 200 OK. Because like if you put it into DynamoDB, you can still do your retrieval. You'll just get a cache miss. But for whatever reason, I didn't really like this as much. We're not going to call. So this one would be the two requests, two writes approach. Two writes approach. And this one's going to be the message broker approach. Yeah, okay, so you do the write to the link DB, and then you would attempt the write to the cache, and then again, you would check the cache first. If you didn't persist it, or your cache expired, then you would have to do your check against the link DB. There's that one, and then I had the message broker idea, and then even better is just using a DB trigger though. So in the fall, I have no idea. I think I had heard that DB triggers have like a lot of overhead and that they're flaky for whatever reason. I thought I saw that in here. Why did I make the text so small? That was weird. Sorry, that was probably obnoxious for you guys. Here, I'm going to make these really big. There we go. Okay, so now we're going to talk about the DB trigger approach. Is that we're just going to go ahead and have a DB trigger on DynamoDB. Got DynamoDB right here, which does support DB triggers. And we're still just kind of doing an LRU cache. We are going to cover an LFU cache later. And we're just going to do change data capture with a, I don't know if it's even called change data capture, because the record itself is, we're basically just kind of doing event sourcing. We're basically just doing event sourcing. So I don't know if the records themselves aren't actually changing. I don't know if it would still be called change data capture. Usually I hear that term used in this context of where you're replicating stuff downstream to, you might have like a read optimized view or something downstream, but you would just have just the same data down here. You just have like an LRU cache that might expire. You have your redirect service over here. You got a request comes in. You are going to check that cache first, which is a lot faster. And then if it's cache miss, you would have to hit the database, DynamoDB, for your cache miss if you get one of those, and then you would be able to return the response. Right, so those are the big caching approaches that I definitely wanted to cover. We're also going to do some stuff with LFU. We should probably do lazy loaded cache as well. But yeah, we're already at 5 approaches. I'm going to go ahead and check for any comments right now. But this is the approach from the fall. And I was like, I think I just had this one and maybe one other. And so I'm just really not happy with that anymore. I was like, we can definitely do better right now. Okay, let's see what's in the chat. For part of the partition key, do we need to add a separate field with concatenated string in the, you do not have to make the concatenated attribute separately. I think that's what you're asking. You do not have to explicitly make a new field with the other attributes concatenated together. That totally makes sense. So a concatenated index is literally when you just specify 2 attributes together. I kind of want to show you guys create index SQL. Yeah, I really want to show you this. It blew somebody's mind the other week, is that there's actually it's just here in W3 schools, is that this is how you create another index. So you can create a table. So you'd have like a table that has, however many attributes. It has attribute A, B, C, D, and each of them have their own values. We're gonna have a user ID. We would have some kind of other information. We would say maybe bioinfo. Hi, I'm Yubidasu. And then you could have like a link. Fine. And so you would have your primary key, so you usually have to have your primary key. And then if you wanted to also have really fast lookups by some other attribute like this, if you wanted to have quick, you could have what if you had role? So this would be say standard, premium, moderator, admin. And if you wanted log in lookup for this, you'd have to add a secondary index over here. And by default, the attributes are not going to be, they're not going to have a secondary index by default. So you would have to do this in order to add the secondary index. And you can specify it as like a B tree, R tree, it could be an inverted index. But if you want to have other fields index, you have to specify that. And then in that B tree created for the new index, it would only have this info in the node by default. If you wanted extra info just to make it if you're going to do this a lot, it would usually be with just the username in the first clause, that select statement. You might want to do a clustered index, also have it in there to not have to do a second hit against disk. If you wanted it to be by this and then by this, you would, so a concatenated index, you would index it as you would index it by role and then by B. That would be a concatenated index. I think it would just be special syntax over here. You wouldn't have to create a new attribute for it. Create an index on a combination of columns. You can list them out. So index by last name and then first name. So that would be a concatenated index right there. I don't think it talks about clustered index here at all. But you can also specify B tree versus R tree. There's syntax for that in PostgreSQL. This blew somebody's mind the other week, I think. So I just wanted to make sure that I covered it. Yeah. I'm going to cover a couple more questions in chat and I'll keep going with some more approaches. For the naive approach, what if writing to LinkDB fails, but writes to cache succeeds? So up here in 3. Well, so if you fail the approach to the LinkDB, if you fail that, that's your source of truth. That's your system of record. So if this fails, you actually would not write to cache. You'd actually just return a 50x or something like that. So you'd actually not hit the cache. You'd actually fail the request. You'd return a 50x. It's not sufficient to have something in cache since we have a time to live on it. It's an LRU. So we're not able to guarantee long-term persistence if it's in the cache. I mean, there's ways to like make it work where you maybe have the DB trigger on the cache, but I'd much rather have the DB trigger come off of this. If this is failing, which should be very rare if it's DynamoDB, like your data store should be very dependable. I'd rather just return a 50x. Your cache can fail because that's not the system of record, but your system of record, if it's not able to give you a thumbs up, you should fail the request. I think that's pretty standard. Yeah, if you can't persist it to system of record, you should totally fail the request. How to handle conflicts in UUID. You shouldn't have any. You shouldn't have any. If you're doing machine ID and then that, it shouldn't result in a write conflict. Write conflicts only happen if you have concurrent writes for the same primary key. So if you can guarantee that all of your writes are going to unique different IDs, you should be fine. And in our case, that would actually be how this would work out. It would require the UUID service to have a bug in it in order for that to happen, and you don't need a design for that. So yeah, we should be good. Is it also possible to just write to DB, then rely on cache aside? Cache aside is actually what I intended for. This is cache aside. This is cache aside, I think. That's a more accurate description as cache aside. Don Martin's Systems Design Primer is really great for those database, those caching terms. Let's look for. Yeah, I'm fairly certain that what we just did there is cache. He even has little code in here. I don't remember that. And so here, if he gets it from the cache, if it's actually, if it's not, user is not, so as in a cache miss, query the database. If it's in the database, put it in the cache. Well, so that's for a cache miss. It doesn't talk about, yeah, so cache aside, that's this. Right through, oh, it has it going to the cache first. That's weird. I would have wanted it to hit the database first. Or is hitting the database first called cache write back? Is write back when you write to the database? Try to find that. Find cache. I don't like, oh, Add event to queue. It's, oh, what? He even has a broker approach on here. That's so weird. Yeah, I would have thought write through would have hit the database first and not the cache. Um, so there's also like L2 cache in like your CPU as opposed to RAM or disk. And so a lot of these caching concepts actually come from that, where they're not from distributed systems land. They're actually from like CPU concepts and like your L2 cache and your CPU. It's like a CPU architecture thing. And some of these concepts, but a lot of this concept stuff comes from there, and you do actually have like an LRU versus an LFU cache in your CPU. And I don't know if some of these really make that much sense, and some of these are a little bit weird to translate, I think, to database land. But my understanding of write through was that I really think you would want to hit your persistent store first. I was really thinking that this one would be write through. I don't really agree with I don't know why you would want to hit your cache first, because then that doesn't guarantee that it's persisted. You might give your user a thumbs up response just when you touch the cache, and it wouldn't actually make it to disk. And that sounds weird to me. I think you really want to guarantee that it hits your database, your system of record, before you give your user a thumbs up. And unless you're putting it in this, a stream is as good as a system of record. Because a stream, if it's Kafka, it is writing it to its own disk, and it's replicating it. It has its own internal implementation of Raft, so I think it's like redundantly replicated, and you usually have a what is it, a retention policy of like a few weeks or something, and so like you're not gonna lose that data after it touches Kafka, unless the engineer is running the things like really screw up, like really bad. So it's pretty much. Why do I have this here for? I didn't mean to have broker here for this approach. Oh man, how did I miss that? This is what I meant. Yeah, this is what I meant. I don't know I had the broker there. I'm so sorry about that. Yeah, that's what I meant by write through, is that you hit the system record first, and then it does a DB trigger to get it into the cache. Okay, I'm going to go through the messages again. God, I hope I didn't confuse the hell out of you guys. So cache aside though, that I'm pretty sure that what I did with, I'm fairly certain that approach 3 is roughly cache aside. If anyone disagrees with that, like feel free to let me know. Like I'm fairly certain that this is basically how you do cache aside. But I love seeing other people's interpretations. Okay, do we need user and DB schema? Ooh, wouldn't we need timestamp? I guess timestamp would maybe be a good thing to have in there. Let's maybe just go ahead and, yeah, so we could go ahead and stick. I think timestamp would possibly make sense. It could be, I could see uses for that. And I was thinking user, because like sometimes for the analytics stuff, which was out of scope, but it's like I still want to have it there, even though I don't want to actually cover the analytics aspect. So you would also have like a counter thing. I guess the counter thing could maybe be in a different database where it's like the data warehouse or whatever the heck you want to do. Or you could even just have it directly in the, so you have a view counter. Well, it wouldn't actually be views. It'd be unique user IDs. It'd be unique viewers counting. It's the redirect counter. It's the redirect counter. If you're doing permanent redirects, that would just mean that if they access it a second time, they'd get that 304, or they would go directly there. And so it's only kind of doing unique users. But that could even be something that you could have in the schema, or it could be done downstream. So it's like an optional attribute. You don't necessarily need it there. How would timestamp help? I think you would maybe want to know like what date you created a link. You might want to know what day you created a link. Usually it shows that on stuff like tinyURL is like when you created a URL to help with some context on it. Handle conflicts in case of millions or more users trying to shorten URLs. Your sequencer should handle that. Your sequencer should definitely be able to handle that. If so the way you would scale it out is that you would just throw more machines at it. And each machine should definitely be sequencing it properly. Each machine doesn't have that clock sync issue, should have a monotonic counter. So you just throw more machines at it, be scaled out horizontally, and the monotonic counter should still be just fine on each one. Your machine IDs should not be having conflicts. I mean, so like if you want to get really crazy with it, you know, you can have like 1 million machines doing sequencing, and each one has a monotonic counter. But you would never have any write conflicts here. It shouldn't really happen. Like I said, sequencers are a thing that are used in they are used for leaderless databases to implement linearizability. So like the theory's there. And in fact, I think this concept is even talked about by Leslie Lamport for causal consistency, kind of. He kind of talks about this in either, I always mix these up, like vector clocks, logical clocks, Lamport timestamps, one of those things. It has this idea of a machine ID coupled with a monotonic counter. You can't get a write conflict with it. Yeah. Get details of created and updated time and expiring the short URL. Yeah, okay. So if you're gonna do a time to live, yeah, you definitely need a timestamp for time to live. Yeah, I definitely agree with that. How to handle duplicate URL request from user. User submitted URL and resubmits after a few weeks later. Short URL. Well, so that could actually be a valid use case. You could actually have multiple entries for the same URL. So let's say that multiple users wanted to link to the exact same URL of //Wikipedia, wikipedia.com/system design. So you might have literally multiple users that like if there's like a popular YouTube video or something, and each of them want to short link it, and they might each want to have their own analytics of how many people they've linked to a popular YouTube video. It could make sense. Also, it's a marketing thing, is that sometimes marketers might have multiple short links to the same landing page. They might have multiple different, so let's say that they are marketing Notion. Notion is a Y Combinator startups. They're definitely dumping a lot of money on marketing, and so you'd have multiple different tiny URLs, shortened links. They want to figure out where they're what ads are working really effectively and which ones aren't. And so you might have multiple tiny URLs from the same company for the same website, and they would actually want to have distinct URLs just to figure out which ad with which shortened link is really working well for them and which one's driving traffic. So I think that's a valid use case. Yeah. Okay. How to make this service global? What changed? Oh yeah, yeah. So you would what I've seen is that you would basically have like a regional setup of the database in each region. You would just copy paste this whole thing in each region of the world. So like you would have and you don't have to have it in like literally every country gets its own copy paste. You would just need it to be in like you just take like US West 2, you would have like Asia copy, have your Europe copy, you might have your South America copy. You might have a copy just for Africa if you get enough traffic there. You could have East Europe and West Europe. Europe's kind of big. You could have it depends on how many regions you have and what kind of latency you want, but you could leave it at just 4 and that would be easily enough. For that's like enough of a latency guarantee for 99% of global services. You need to be like youtube.com or like google.com to need much more than 4 regions. You like a lot of stuff that handles like thousands of TPS is fine with just 4 regions. You just copy paste this whole thing like that. Right, has to check cache and DB. I'm gonna make this my last question before I do a couple of other approaches, then I'll get back to the YouTube chat and try out some more. Right, has to check cache and DB. The short URL for the duplicate long is this and would return error. Let's check cache and DB. I think you're answering somebody else's question. So I'm going to keep moving on. Let me know if you want me to get back to that though. Okay. Lazy loaded cache. It's one of the things I wanted to cover. Lazy loaded cache. I also want to do okay, LFU stuff. There's 2 different things for LFU that I want to cover. Can't really remember anything else. Yeah, I'll cover the LFU cache though. Okay, yeah, we're gonna copy paste this one for the lazy loaded cache. So you write it to the link DB. If you've written your thing over to the right DB, oops. And then you got your cache over here. You're not writing it directly to there. Instead, what you've got is you're going to go ahead and you're going to check your cache. And of course, on the first hit, it's going to be a miss. So you got your cache miss. So you're just going to have cache misses indefinitely. Well, so you're going to hit this. And then to make sure that you don't do cache misses indefinitely, you're going to go ahead and you're going to write it over to here. And that's one way. So I know with CDNs, there's this concept called a pull-based CDN as opposed to a push-based CDN. I don't know if you can set this up with Redis. This one is push-based. And then we're going to talk about pull-based. I don't know if you can actually set this up with Redis though, but I just want to cover the concept of it. So you got your first hit against the cache. You've written it, returned. You got a hit against the cache. And then your cache is smart. And it's actually going to go ahead and look it up against the database. It's going to go ahead and make the call to your data store itself and try and find it there. And if it's not there, it'll also be able to handle the miss too. And then it's going to go ahead and return. But it's going to try and pull it into its. So if it has a miss and then it looks up over here and it finds a record, it'll go ahead and hold it over here in the cache. And then it returns the response. I don't know if you can do that with Redis though. I have no idea if you can actually do that with Redis. But that is the two ways to do a lazy loaded cache. LFU stuff. I do want to hit LFU stuff. I got one. I guess I've got like three things I can do there. So like first of all, you can just go ahead and switch Redis over to LFU mode. Like it literally supports LFU mode instead of L or U. I feel like this lazy loaded cache thing does apply to like other stuff over here. Is like when your cache expires for like just the DB trigger approach, when your cache expires, like, hey, you might get a sudden burst of traffic for one of your old URLs somehow. And so like you might similarly do, you get your miss against the cache, you have your miss over here, you got to look it up against the DB again. Are you just going to return it right away, or are you going to go ahead and write it back? So like lazy load stuff, you can do eager loading and lazy loading as well. And then I don't know if Redis actually supports doing a pool-based strategy. But again, you can do lazy loaded plus eager loaded, and then you can just switch from LRU mode to LFU mode on the cache just directly. It just inherently works like that. But there's two crazier approaches for LFU that are, if you just do plain old LFU and you've sharded your I can go ahead and write this. I can go ahead and start drawing this out. I should talk about how your cache can be sharded, and then it's not globally LFU, or it's not globally LRU. So we have what is this, approach 8 is locally LFU. And so again, you just got your DB trigger, and then this thing is going to be, have it sharded into just like your regular database can be sharded. You might have shards of the cache. You can shard your cache by you can use the prefix you'd have. One is like the range of like A through F for the first letter of the UID, and the next one is like G through I don't know, M, and then you have N through Z over here. And you're just doing DB triggers out to the cache. And then when you have LFU, it might just be to the individual node of the cache. And then I wanted to cover this just because I thought it was really interesting, is trying to make it a global LFU cache. So we're going to first do, so when you're doing your redirects, you're having these views pass through here, and you're doing a hit against either the database or the cache, but then you can also like log it. You might like log it to some local logs. You might have a daemon that picks up on these logs. You might put them into Kafka or something. So just be doing these writes off to over here. And what you could do is you would have a data warehouse. These approaches are a little bit crazy. I just thought they were thought-provoking, is why I want to cover them. And so you could, of course, have some Lambda triggers. I'll get to the YouTube comments and questions a little bit more after I cover these last two approaches. So you would have to pull in you have to pull the data off of your stream. It's not push based. stick it in the data warehouse, and then you can do these processing jobs to look up the most commonly looked up, most commonly viewed short links. I'd imagine something like this would kind of exist anyways, just for the analytics stuff that they might serve up to the link shorteners over here. You'd probably have some kind of analytics pipeline anyways. And so you'd probably still be logging those views regardless. But you could even have some kind of processing job. So it would be like MapReduce or Spark. And so you'd figure out the most popular links over here, and then you can load them into the cache with a time to live of so let's say that you're running this. So run every hour, and you set records with a TTL of 5 hours. And so you're continuously refreshing the ones that remain popular and they never fall out of the cache. So this would kind of ensure globally in LFU globally across all the caches is what this would kind of ensure. And then I had another approach is you don't actually have to use a full data warehouse. You can make it a little bit more real time, or you don't necessarily need to care about accuracy as much. A difference of like just a couple isn't really going to make a huge difference. So you like don't really need a full data warehouse necessarily. You can just go ahead and shorten this into Flink. Just go ahead and use Flink. Why is it doing that to me? Okay, here we go. How did it do that? Sorry, I'm apparently really bad with technology. I don't know what it was flipping over to. Okay, so we got Flink over here for real-time analytics. And then you can just go ahead and have some kind of periodic thing that is just doing loading it into the caches instead. Again, these approaches are a little crazy. I just thought they were kind of thought-provoking, so that's why I kind of wanted to share them, is that somebody was asking about an LFU approach for this problem. And that's why I really wanted to cover these LFU approaches a little bit. So this is globally LFU and real time. And then we have globally LFU batch. And that is approach 9 and 10. Cool. Yeah, so these are a little bit crazy. I just really want to make sure that I record them though, because I just thought they were interesting. They might be useful for when we're covering some of the other caching problems in the future. I might do something a little bit similar to this. Yeah, but you can totally just do local LFU and it's probably gonna be close enough if you wanted to do that approach. All right, I'm gonna look through the chat for any further questions that I've missed. Approach 4, if write to database fails, what will the user see? Did I already answer that? No, I didn't. Okay, so you write to the database first, and then you would try to the cache, and then it's like, what if you're right to that? And so you've already returned a thumbs up to the user, and so you're like, yep, I've got it, it's on Kafka. You would retry. You would retry the write with the task runner. If it keeps failing, your engineers should get paged. So that's happened before. I was at Amazon for 3 years, and we've of course had really big outages of AWS services itself. During my time working at Amazon, I think there was even a Kinesis outage. Thank God I was not on call during that. That must have been nuts. If your self-hosted Kafka setup is down for the whole company and it's Amazon, so it'd also be down for, half the internet, that'd be nuts. Like, you just can't account for that. Like, you don't design for that. You can't account for that. You shouldn't design for that. Netflix might, but they're crazy and they have crap like Chaos Monkey, but otherwise you literally you shouldn't be designing for that. So anyways, here you should just be retrying. You should you should depend on this thing to actually stay up. It shouldn't actually, you should just not design for the broker itself failing. It should always stay there. And then you set your retention policy to something like several weeks. And so then if it's not making it into the database, you literally have several weeks to figure out why. And you can just retry until that works. You should be retrying with exponential back off with jittering. Sorry, God, my tongue is so tied right now. You should be retrying using exponential back off with jittering. I'm going to write that. There's some principal engineer at Amazon that is like really big on this concept. It's just something to make sure that you don't have retry storms. So if the database really is out for a 15-minute period, you're going to start getting hammered by retries you would literally immediately be getting hammered by retries unless you have some kind of back off to like make sure you don't retry for a certain period of time. And so this is just a thing to avoid a concept of what's called retry storms, I believe. I think there's another guy, Asley Engineer, I think he talks about like this thing called the thundering herd problem. It's just when you get slammed by a bunch of traffic at once. And retry storms are a very prominent example of that happening, is that everyone's going to do their retries at once. Jittering is to avoid it being in this like regular period in the exponential back off, but this is just like a strategy for retries for really big outages. But it shouldn't be down so long that you actually lose the data. While it's down though, it's not going to be handling those redirects. Yeah, it would not be handling those redirects, which would probably be depending on your use case, that should probably be fine. Like, it's not the end of the world if people aren't getting redirected. It wouldn't matter if it's something like a payment service, a payment processor or something. It could actually make a difference. But link shortener is not such a crucial service where a little bit of downtime is not going to be the end of the world for a tiny URL. But another alternative is where you might have just, if you did make it strongly consistent, like with this approach, you shouldn't be returning a success back to the user unless you are immediately able to do reads over here. So if you set up DynamoDB with strong read consistency, you wouldn't be giving the end user a thumbs up unless you're immediately able to service some reads off of that data store. The data store could, of course, go down, but like if it's down, that means that it's down for all the users, and then DynamoDB is having an outage. So it's like you can't really design for that. There's limits to how much you can design for, and DynamoDB itself being down for all AWS users is one of those things that it's kind of unreasonable to design for 99% of the time. But yeah, so just going ahead and giving them the fail right away is maybe another alternative there. Okay, I'm going to keep going through these questions. I probably spent a little more time on that than I should have. Are we also having any limits in terms of size of the shortened URL? I don't, well, URLs themselves actually have a character limit of about like 2048. So URLs have a native limit. That's, you can work around it with post requests, but that's actually like a thing that you actually have to account for sometimes in terms of GET requests, is that there's only so much data that you can actually pass in a GET request. And then if you hit that limit, you are forced to convert your communication style over to post requests just to kind of work around it. I think it's at around, it's probably around like 2048 characters. For the shortened URL, like this part here with the sequence, like you should be trying to do some kind of hashing trick to make it as short as possible. It is a short URL as possible, but it's a short URL. It should be short, and so you should just be doing whatever hashing trickery you can to make it as short as possible. I don't want to get into that because it's not really a distributed systems problem. It's like a hashing and math trick. It's not really interesting to me. Each region has different DB. Yeah. Yep. Yeah. Each region has its own. So like if, for example, you were not using DynamoDB, if you were using PostgreSQL and rolling it yourself, yeah, you'd have a different instance of PostgreSQL set up in each region. Yes, so that is exactly what I was describing. Is when you put your data closer to the users, retrieving that data is going to be a lot faster. So for your users over in Asia, if you have a user in Japan, instead of having to have your request get routed all the way over to New York City or Seattle, it's just able to get routed to a database that's hosted over in Japan. When you're doing global replication, though, so you'd have your persistent store, your linked DB might be local to each region, but you would maybe have a regional replica. So in your North America region, you would maybe have a replica of popular links that were shortened over in Asia, and over in South America and Europe, you would have replicas of that database, the popular links from those databases over in North America. You can even just have read replicas of the data store itself over in all the other regions, just read replicas, which is cheaper than cache. It's cheaper to have just a read replica because disk storage is cheaper than RAM storage. So that could even be another option for trying to bring it down, is that if you have just so many tail end queries, as opposed to having popular shortened links that are the bulk of your traffic, if there's just way more tail end, it might make more sense to have those read replicas than to have a cache for the regional replicas. So I should maybe record that is hashing. That's actually a really fascinating thing that I don't think I've gone into, and maybe not even any of the other videos, but yeah, that's a little more interesting for handling global services. I'm going to get this Zoom question that I've neglected for a couple of minutes here. Oh, come on, let's copy that. There we go. I know you have mentioned that sequencer would handle things for write conflicts. It would, yes, it just solves write conflicts. You should not have any write conflicts. If we are having our services in multiple regions, how do we make sure that each of them is returning unique short URLs? You would, okay, let me draw a map. It's okay. Let me draw a map. So we've got our map of the world. And then we're going to have NA. We're going to have South America. We're going to have a big old blob for Asia. We got Europe, Africa, Australia. And so we're going to have machine one. We say one, large. Let's zoom in. We have machine one there. And we're going to have machine two. And we're going to have a machine three over on the East Coast. We're going to have 4 and 5 over in China or Japan. So I mean, when you're setting up the machines, like provisioning the machines, they would need to be globally coordinated, sure. But that would be handled by your infrastructure setup stuff. So like Kubernetes, you would maybe have like Kubernetes. You just have like one little thing of like Kubernetes like over here is that you would have your Kubernetes set up in just one region. You don't need to have your infrastructure provisioning stuff globally. It just needs to be over here and it just gets heartbeats from everybody. And this thing is going to have linearizable consistency. Kubernetes does have this thing inside of it called etc daemon, which is a linearizable key value store. And it also, I think it does some kind of crap with like Paxos internally, but like this thing's linearizable and it's going to provision all your stuff linearizable. Maybe this is what you're asking about is the infrastructure provisioning would be linearizable, but you do not need to have linearizability on the actual sequencers because all the sequencers are guaranteed to have a unique number, but you don't need linearizability on the machines themselves, I feel. You need linearizability whenever it's total ordering. If you need total order broadcast is when you require it's when you require a global total ordering is when you need linearizability. Linearizability. There's ways that you can guarantee everything to be unique without actually needing total ordering. And if you just need everything to be unique, that's actually a lower consistency level than linearizability. Linearizability is when you need to know, it's when everything's unique and every single record is in a total ordering. We don't need that here. We don't need to guarantee the total ordering. We just need to have uniqueness guaranteed. Actually, shoot, I know, I thought Martin Kleppmann had some kind of thing about guaranteeing unique IDs and usernames. You're making me doubt myself here, but I thought there was a way that you were able to guarantee this. Maybe it's causal ordering is all we need. I thought uniqueness constraints didn't need a total ordering though. I thought there was a way around it. Shoot. Yeah, now I need to recheck that. There was definitely something in DDIA where Martin Kleppmann was talking about uniqueness, and he used an example of a username registration service, and that like that was I think it was a uniqueness constraint. If you needed to guarantee a uniqueness constraint in user registration, I think that definitely did require linearizability on the whole thing. But with a sequencer, it's not, you're not able to have two different users registering the same sequencer ID because it's like individually provisioned at every spot. Here's a couple. I'll throw a couple of terms out here. So Lamport timestamps. There's vector clocks. You got logical clocks. I think there's something in database internals for vector clocks. There's something where you're able to use vector clocks to guarantee it was a total ordering that violates causality. That's what what we're getting here is a total ordering that violates causality. And it's like the thing that you can use for causal consistency provides that. It's a total ordering that does not preserve causality. That's what we have, and you don't need linearizability for that. Yeah, you were really making me doubt myself there. You were really making me doubt myself. I was like, shoot, there is actually a thing in DDIA where he talks about username registration. It's just that we don't need to preserve causality here. We don't need to guarantee fairness. We don't need to have total ordering that guarantees fairness. We don't. So we're able to work around that. It's such a hard topic, though. I'd definitely been going hard on these books for like at least a solid 6 to 12 months when I had really dug into that little section. And like the wording is like, it's really hard to pay attention to the wording. It like contradicts itself in some spots, but like it's just, yeah, it violates causality. We have a total ordering that violates causality. That's what makes this so special. Yeah. The global setup, does it make sense? One global DB for source of truth and have the rest set up copied for multiple. Does it make sense? So each region, so you have regional sources of truth, and then you have replicas in the other regions. So it's kind of like partitioning in a partitioned database, is that you have different nodes that are the source of, they're the leader for certain replicas. So you don't have one single machine that is a source of truth when you do partitioning. You have like multiple, and then you have like read replicas all over the place. I'm gonna do this really quick. I am just not having a good day with technology today for some reason. So you would have, let's make this one green and solid green. We're gonna make this one solid green. And then we're gonna have a pair of squares that are going to be, we'll pick blue. A pair of squares in each read. So we're gonna have a Europe square, have two squares in each region. And these are read replicas. Two over here and two over here. And so these are leader nodes. And it's going to go ahead and it's going to make a copy to over here, curved. And we're also going to make a copy to over here. And we've also got this guy. He is a regional leader. He's going to make a clone over there. And he's also going to make a clone to over here. So it's a regional source of truth. And you just stick a read replica everywhere else. And it's very similar to just what you always do in partitioning for a database. You implement that in your service, right? If it doesn't exist in the cache, then the request goes to DB, loads into cache, and return it. I don't remember context on this. This in the cache, then the request goes. Maybe it was the pool-based thing, or it was one of these. But when you do stuff in your service, instead of on the in the database itself, so like in particular with the lazy loading as opposed to the pool-based thing, that's bad because it results in more hops. So over here you have a miss, and then you do a pull over here, and then you do another write over here. As opposed to over here, it comes in, you have a miss, and then you do a pull there and it's back. So like we can look at the one directional hops is that we have 1, 2, 3, 4, 5, 6 hops there, while over here you have a miss, it's just 1, 2, 3, 4. So if you can avoid implementing it in the service, it would cut down on hops. Okay, can we download your Excalibur library? I should post that in the README. I'll post that in the README of my Discord, and I'll also stick it in the description of this video. I've not been on the ball lately, and I've been taking up to a whole week to upload the files. I'm sorry about that, but I'll make sure that it'll be in the README on Discord. And in the description for this video. Yeah, I can do that. Yeah, I probably should have done that a while ago. They do look, like what you get by default with Excalibur is not great. There's you're able to get like more somewhere. Browse libraries. Yeah, I got my components from, I think, Browse libraries, but then I've like done some extra stuff, and I imagine everyone would just like it if they could just use the same components and everybody could just use standard stuff to draw the same looking diagrams. I think that's been something that has irked me a little bit about looking at content that other people make, is that like they're using different drawing software, and so then it looks different and it like bugs me. It's important to kind of keep like an open mind and be like, I don't like this. Why don't I like it? Just because it's different doesn't mean that it's bad. Like that's just such an obvious thing, but it's like just because it's different, it's not bad, but like it just helps to be like communicating diagrams in like the same language. Anyways, I'll upload that. It's also nice because it's colorful. I think that was one of the things that first drove me to start using to start kind of like making my own library, is that I was like, oh, adding colors would really just make these a lot more visually appealing to people. And then it's a lot quicker to identify components like my data stores, my brokers. I always, use the same thing for the brokers and the data stores, or the workers or task runners. It makes it a lot easier to figure out what's going on in the picture when you're using some color coding on it. I totally should have done this earlier though, yeah. Okay, lazy loading cache strategy is same as cache aside. I think so. Cache aside can be eager loaded. You can do cache aside that's eager loaded. So over here, so approach 3 is cache aside with eager loading. while I guess, what is it? Approach 6. Approach 6 is cache aside with lazy loading. Yeah. And then like, I don't know how to do lazy loading without cache aside, unless Redis does support doing this like pull-based thing. I guess that is pretty accurate though. I guess you could say that lazy loading is cache aside. Oh, I don't know if Redis supports a lazy queue without cache aside. And which one was pull base 7? What about application servers? Update DB, push updates into PubSub to populate cache. What about application servers? Update the DB, push updates into PubSub to populate the cache. So you do like a DB trigger, but it goes to a broker first. I think I can see what you're talking about. Yeah, so so what you're describing is I'm going to take this. Why am I having such a hard day with technology today? I think you're talking about keeping the DB trigger, and then you have this, and then the cache is populated like downstream, kind of like this. Then you have your Lambda triggers over here. So for the globally distributed one, like I think that would make sense for the globally distributed read replicas. Because like you're gonna kind of have to write to like a couple of different caches there, and it's like around the world. So let's call this approach 11. Chat's approach. I think this would make a lot of sense for the globally distributed read replicas. Yeah, I can totally see that for globally distributed read replicas. It would be it'd probably be a hassle. In fact, actually, this is what I've usually seen with CDC with DB triggers. Is usually you don't actually write directly from one database to the other. What I saw at Amazon was actually we did have a broker between the two databases like this, even though it might not have been across regions. I just like, so if I was actually drawing all this out every single time I had CDC with DB trigger, so like if we saw over in, yeah, just approach 5, if I drew out that broker between the two and included the task runners, which you like, if you're going to fully formalize out the whole diagram, like Kafka's not push based, you would have to pull stuff off of it in order to write it. So if I actually drew this out every single time, it would be quite a tedious task, because some of my diagrams have like a lot of CDC going on with them, and I think this is actually how you would do it most of the time, but I don't want to draw it out like that every single time. And this would particularly make sense for the globally distributed case. So Flink is a real-time database. Flink is a real-time analytics solution. It's it's pretty rare component. It is rather rare. It does min, count, sketch. It's a probabilistic algorithm, and so usually when you do analytics, OLAP is really expensive. And so like if you're going to do like a map produce job, it might take like 8 hours. And if you're trying to make it real time though, in order to like, so if you want to get those OLAP responses in 5 seconds instead of 8 hours, what you do is you run this probabilistic algorithm called min count sketch, and then you get your response in 5 seconds. It's off by a little bit. It's not perfectly accurate because it's probabilistic, but that's good enough a lot of times. And so you just go ahead and get your probabilistic estimate. That's going to be off by a little bit. Sometimes it is pretty accurate, but in most of the use cases where you're applying Flink, you don't really care about having perfect accuracy. So that's where you use it. It's fast OLAP stuff. Yeah. For LFU approach, why not update the count directly from the service instead of using the queue? Why not just update the count directly from the service instead of using the queue? Well, so you're getting a windowed counter. So it's like a counter over a window. And so Flink can do a rolling window, while if you're just doing it directly with the data store, it doesn't really do rolling window stuff. Also Flink goes off of a stream. You have it reading from a stream. You don't have Flink, you don't write directly to Flink. Flink reads, it pulls off of a stream is another part of it. It's streaming analytics. So real-time analytics, also called like streaming analytics. It's usually built on top of a stream. The stream can also batch stuff up. It's so another thing that does streaming analytics is Spark actually has can do Spark streams, and Spark does micro batching. And when you're doing reads off of Kafka, each shard supports about 10 reads per second, and I think it'll do like 1,000 messages per read. It's either that or like 10 megabytes per read or something. But it batches up the messages. And so every single pull that you do off of Kafka will have like 1,000 messages or something. And so that fits really well with like the Spark micro batches. So that having the stream there and working in parallel with the Flink component is they're kind of crucial to each other. And then also Flink can do a rolling window counter, which a database on its own. I haven't seen that, at least. I haven't seen databases that do a rolling window. You might have been even suggesting like a CRDT counter, like it's some kind of counter, a total count thing. I haven't thought through that approach a ton, but that could be something else that I investigate for any further work on this problem. But we've already got like 10 or 11 approaches. Okay, how do you handle cores since you're redirecting? So you mean like cross origin what is that? Cross origin what I forget what the heck the rest of that is. So that's like a header thing. That's just like a trust thing. You just that's not really something you really have to worry about a lot in system design, is that you just kind of I guess you can like programmatically set. So when you're giving that 301 back, if there's any issues, I guess you could go ahead and set the target URL as part of the cross origin header. So there might be some kind of programmatic manipulation of your HTTP headers to tell it to trust the target destination. Original, no. What else have we got? I'm gonna do these last two questions, then call it a night. Anything else can be on Discord. Are you planning to use JWT token? So this is auth stuff. The user enters the password for signing up for your service. So this is auth stuff. I did kind of choose to ignore this. When user enters the password for signing up, a SHA-256 on client side send the cryptographic cache to the server. Oh, so this is, you're kind of talking about password handling. This is kind of out of scope for what I wanted to cover, but I could try and take a shot at it. Is with password storage, I think with passwords, you usually send a hash. Well, so you do a TCP handshake with, and you would usually use SSL. So to begin with, you should have HTTPS. You do some kind of handshake. You shouldn't really. So with SSL, you shouldn't really have man in the middle attacks. So it should be encrypted to begin with. I think with passwords, you usually send just the hash, though, I thought. But like with storing it, so you should also be salting your passwords. With storing password, it should definitely be the hash. I don't know how the heck JWT tokens work. I know that is a thing for auth. But this isn't really a video for going deep on auth. That's gonna be a pretty standard. Auth is kind of like the same for every single service that you look at. I think having a single sign-on component is a single sign-on service is like a thing that you would sometimes see specifically asked as its own system design question. Single sign-on is maybe one system design question that some people get asked. So I mean, it is a thing that like could be system design related, but like I wasn't planning on going super deep on auth in at least in this session, which reminds me I should maybe cover single sign-on design in like a separate video or something. But yeah, I can't give you the best answer on that right here. Yeah, sorry. Can we say it's an eventual consistent system? So that depends on which approach we are going with. And then in some of the approaches, you can even go with a couple of different ways. So with 1, 2, and 3, you can do strong read consistency. Let me go ahead and do this. So supports strong read consistency. And that's a can. You don't have to do strong read consistency. You can always do eventually consistent mode on DynamoDB alternatively. And then we're going to have the eventual consistency only approaches. Okay, so 1, 2, and 3 are definitely going to be able to support strong read consistency. 4 is only going to be able to support eventual consistency. 5 can do strong read consistency. What have we got? 6 is able to support strong read consistency. 7, I don't know how in the I guess that one supports stronger read consistency because it should be doing the pull itself. It's kind of like just an alternative request response flow to 6, but the cache itself should be calling the data store in this one, and then the data store over here would be DynamoDB, which you can turn on strong read consistency for. It would make the call there. So I guess 7 can do strong read consistency, although I just don't know if Redis is even able to support this call and response style. I don't know if you can set up Redis to be pull based. 8 is also strong read consistency. It can do it. 9 is, yeah. I think it's just the one that only does eventual consistency. 10 is, yeah, strong read consistency. What was 11? So for a cache miss, I think you would still be able to do, I think you would still do this for a cache miss. Unless you were doing read replicas, and then it's some of the regions would be eventual consistency, while the, yeah, so if this was read replicas instead of a cache, that would be eventual consistency. So cool. I'll make this the last question for tonight. I lied. This is my last question for tonight. And then other questions, let's handle them in Discord if there's any further questions. How can we request new problems to be discussed? Interested to discuss design a system for displaying advertisements next to search results. Oh, ad click. Oh, so that would be like the ad placement for the ad click counter. That would be really cool. Well, okay. It's actually, that's like ad click prediction. It's the part between ad click prediction, which was in the Alex Shu ML book. It's the part between ad click prediction and ad click counter. And I think with ad click counter, it's easy to brush that ad placement part off. I am actually kind of considering doing ad click counter, redoing it sometime within the next month or two, kind of like we just did with tinyURL. I'm actually no longer 100% happy with ad click counter, although it wasn't as horrible as my original coverage of tinyURL, I guess I could say. You can request problems in the Discord. I'm pretty good at watching that. I did used to have a Google Forms thing. It's kind of Google form you could fill out. It was in my earlier videos. I'm not fantastic at looking at it, but I do look at it, I think, still every month or so. And yeah, I mean, so comments on the Discord works. Yeah, I'll put this on my list of stuff to cover though. I think that is a pretty cool idea. I think that is a pretty cool idea. I think I can cover that in my when I recover the add click counter problem. That's definitely something that I think is brushed under the rug for the usual coverage of add click counter. Okay, I think we can call it a night. Thanks a ton for watching, guys. I hope you had fun. I hope you guys are pretty happy with these results. If there's anything else, if there's any other approaches that you think are missing, or that if you just have some thoughts on something that could have been improved, or if there's any other approaches that you guys think would be interesting to consider, I'd be happy to hear them. Drop them in the Discord thread for this problem. That would be great. Otherwise, thanks for joining. I hope you guys had fun. I appreciate it. You guys have a wonderful night. Thanks for joining. See ya.